क्या क्लास चल रही है? क्या कौन सा? ये वाले तो बंद कर दिया जो आप 100 रुपये।
Hello. Hello, good evening, students. Are you able to listen my voice?
Yes, sir.
Okay. Right. Okay, fine. Hello. Hello, good evening, students.
Sir.
Okay, now last class, I think solutions completed, right?
Yes, sir.
Solutions chapter completed. I think the solution assignment also. I sent assignment. How many of you completed? I don't know. Now today we are going to discuss the new lesson, that is electrochemistry. Okay. All of you got assignment, solution assignment. Hello.
Yes, sir.
Followed all of you solutions, sir. Please respond. Okay, now we are going to start the new lesson, that is electrochemistry. Electrochemistry. Okay. Now, what is meant by electrochemistry? So, electrochemistry is the branch of physical chemistry. Okay. Electrochemistry is the electrochemistry is the branch of physical chemistry which deals with the study of electrical energy converted into chemical energy or chemical energy converted into electrical energy, right? And vice versa, and the factors affecting the conductances. Before going to the main electrochemical cells, we should know what is meant by conductances. Now, note down this definition. Now we are going to conductances. Conductance or electric conductance. Here the electric conductors are the substance which allows the current to passes through it is the electric conductors. Now electric conductors again further divide to two types. What are the electric conductors? Electric conductors are further divided into two types. What are two types? There is the first one is electronic conductor and second one is electrolytic conductor. First one is electronic conductor. This one is the electrolytic conductor. So all of you listen carefully. Now, what is electronic conductor? So here electronic conductor means the conductivity is due to flow of free electrons. What is the conductivity? Conductivity is due to flow of free electrons. Here, what is electrolytic conductor? The conductivity is due to flow of free ions, right? Here, what are the example for electronic conductors? Electronic conductors means all metals, metals are some of the minerals, some minerals, and one of the non-metal, graphite also. So that is the graphite. Graphite also can act as electronic conductor due to presence of mobile electrons. Now graphite contains free mobile electrons. Now come to the electrolytic conductance means, what are the electrolytic conductance? So the aqueous solutions of acids. What are the acids? So HCl, H2SO4, RHNO3, right? CH3COOH. These are the electrolytes, as well as bases also. Aqueous solution of bases. What are the bases among? NaOH, KOH, CSOH, etc. And aqueous solutions of salts also. Aqueous solutions of salts like NaCl or K2SO4, etc. Many are there, just giving one or two example. Another thing is molten liquids of salts. What are the molten liquids of Al2SO4 taken thrice, or cryolite, or NaCl, whatever it is. What is meant by molten state and aqueous? Difference between aqueous and molten. Molten state means the substance is subjected to heating until their melting point without adding water. Aqueous means the soluble substance are dissolved in water. That is the aqueous solutions. That is the difference between aqueous and the molten state. Okay, understood all of you? Hello?
Yes, sir, we understood.
Please, okay. Anybody else have doubt? Conductors, conductors are two types. Electric conductors are divided into two types. That is electronic conductor and electrolytic conductor. The first one is electronic conductor. Come to, in electronic conductor, the conductivity is due to flow of free electrons. Examples: metals, some it is not same. 1 minute, here same it. SOM. Here some minerals like salts. Example, if you want minerals, CDS, cadmium sulfide. This mineral can act as electronic conductor, and graphite also can act as electronic conductor, so due to presence of free mobile electrons. Next, come to electrolytic conductors. What are the electrolytic conductors? Due to flow of free ions and aqueous solutions of flow of free ions. What are the examples? Now come to examples: aqueous solutions of acids, aqueous solutions of bases, and molten salts, molten liquids, or that is molten or aqueous solutions of the salts. Okay. Now come to that. Next, can I move this? And now I'm clearing this.
1 second, sir.
Note down first. Okay, right? Next. Completed all of you? Right. Next, come to the electrolytic conductors. Electrolytic conductors. Electrolytic conductors. Now, what is meant by electrolytic conductors? Already we discussed the conductivity exhibited by the flow of free electrons. What is the electrolytic conductors? So, you know already what are the factors affecting electrolytic conductors? Now, come to the factors. Factors affecting on electrolytic conductors. Same. First one is nature of the electrolyte. Nature of the electrolyte means, you know, generally the nature of the electrolyte means the electrolyte contains more number of more means more ionic character. More ionic character means simply ionic substances are completely ionizable, right? So all ionic substances are completely dissociated. So then they can act as good electrolytic conductors, whereas the substances with a covalent nature. You know, covalent nature compounds are deeply ionized or weakly ionized. Say, for example, CH3COOH is the partial ionized weak acid. This is the weak acid. So, this is the covalent character. Not only this is H2S or H2CO3 and HCN. These are all weak acids. Weak acids can act as weak electrolytes. Weak electrolytes. You know, that is the strength of electrolyte also explained by Arrhenius theory. Already studied in Arrhenius theory in Dharma, that is the ionic equilibrium. Hello? Yes. Now I am going to discuss that Arrhenius theory of degree of dissociation. The number of, okay, note it down this one. Nature of the electrolyte. In the nature of the electrolyte only, I'll giving the Arrhenius theory. I'm going to explain the Arrhenius theory of. Arrhenius theory explains the degree of dissociation. Degree of dissociation. What is the degree of dissociation for strong electrolyte or weak electrolyte? See this. So, for example, you can take AB is an acid. If it is a weak acid, how it is dissociated like A plus A. This is the Arrhenius theory. Also, we can take this another. Arrhenius theory of conductance. Arrhenius theory of conductances based on the nature of the electrolyte. Suppose AB is the weak acid, it dissociated as A plus and B minus. A plus and B minus, right? But it is not completely dissociated because it is a weak acid. The weak acid is partially dissociated, and partially dissociated ions are in equilibrium with undissociated acid AB. That equilibrium is formed. So initially, say it is 1 and 0, 0. Now at equilibrium 1 minus alpha, where alpha is the degree of dissociation, a percentage of dissociation quantity, and alpha. But the molar concentration, what is the molar concentration means? So this is the molar concentration. Instead of this, I am writing C. C in the sense it is a molar concentration. It is a C alpha. It is also C alpha. Right? Now applying law of mass action. What is the law of mass action? Ka is equal to, you know what is Ka? Ka means a dissociation constant of weak electrolyte or weak acid. So product of molar concentrations of the products by reactants. That means C alpha into C alpha divided by C into 1 minus alpha. Here C cancel. It becomes C alpha square by 1 minus alpha. What is the dissociation constant? Ka is equal to C alpha square by 1 minus alpha. This also important formula. Note it down. And say equation 1. Now, same this one. From equation 1, okay, now alpha is far less than 1. Then alpha value is negligible in denominator. Now from equation 1, what is that? Ka is equal to, you only tell me, C alpha square, right? Therefore alpha square is equal to Ka by C, or alpha is equal to root over K by C. Here what is alpha? Alpha is equal to degree of dissociation or ionization. Degree of dissociation or ionization. Degree of dissociation or ionization. These are the factors. One factor only. That is the nature of electrolyte. See, understood all of you? Hello? Hello, students?
Yes, sir.
What is alpha? Alpha is the degree of dissociation or ionization of electrolyte. Next, continue, note it down or take the snap. Now I am moving to another page. Next page. Okay.
1 minute, sir.
Okay, right. Okay, now I'm clearing this page. Right. Right. Now, important point, note down. For strong electrolytes, for strong electrolytes, the degree of dissociation is maximum. The degree of dissociation or ionization is maximum. That is maximum is that is equal to 1 only. Weak electrolytes, for weak electrolytes, the degree of dissociation or ionization is less than 1. You know what are the weak electrolytes and strong electrolytes means? Strong electrolytes, weak electrolytes. What are the examples? Strong acids. According to Arrhenius, strong acid means HCl, H2SO4, HNO3, HNO3, okay, HCl, H2SO4, HClO4, and weak strong bases, NaOH, LiOH, RbOH, CesiumOH, and salts, you know, any salts, NaCl, HCl, Na2SO4, etc. Now, weak electrolytes means weak acids. What are the weak acids? H2S, H2CO3, carbonic acid, HCl, hydrogen cyanide, even water also. One more, CH3COOH, acetic acid. And weak base. What are the weak base? NH4OH and FeOH taken twice. Or transitional metal hydroxides also weak. And AlOH taken thrice. BeOH twice. Even MgOH twice also weak only. right? So etc. These are the weak electrolytes. Okay, next, what is the temperature effect? Second one, this is the nature of the electrolyte, that is whether it is ionic or covalent. If it is ionic, means degree of dissociation, that is alpha value increases. That degree of dissociation explained by Arrhenius theory. Now go for second one. Note it down, all of you.
1 minute.
Okay, right?
Yes, sir.
Okay, next. So next one is, what is second one? Temperature of the electrolyte. Temperature of the electrolyte. Temperature of the electrolytes. You can see this. You know, when the conductance is due to flow of free ions, right? If it is temperature increases, the movement of the ions increases, na? By attains kinetic energy. Attains kinetic energy. So that means temperature increases, conductance also increases. Right now, temperature of the electrolyte. So when temperature increases, the electrolytic, sorry, the electrolytic conductance increases, because the movement of free ions increases due to attaining of maximum kinetic energy. So therefore, electrolytic conductance directly proportional to temperature. Okay, not this one. Not done, all of you. Next.
1 second.
Okay, now next factors affecting second one, factors affecting on electronic conductors. Electronic conductors. So factors affecting electronic conductors. Here, see this. First one is nature of the element or metal. Nature of the element. Nature of the element. Second one is temperature. Third is valency of the element. Valence of the element. Okay. Come to now. What is the first one? Nature of the element. Note it down. Temperature, valence. Now I am dropping this. Now, what is the nature of the element? Element, it is maybe metal or non-metal. If it is metal, element is metal, it is a good electronic conductor, right? So that means nature of the element. The element is metal. It can act as good electronic conductor. So generally non-metals except graphite, non-metals are not electronic conductors, or there is nothing electronic insulators. Okay. Next, what is the second one? Again, temperature, right? Temperature effect. Some temperature effect when temperature increases, resistance increases the metals, right? So therefore electronic conductors, therefore the electronic conductance is inversely proportional to the temperature. Understood? So when temperature increases, for example, if you can take iron rod and heat it at certain place, then what is the resistance is developed? Then flow of the electrons is stopped. When flow of electrons stopped, then the conductance decreases. That means electronic conductors are inversely proportional to temperature. Next, what is third one? Third one is the valency of the electrons.
1 second, sir. Let us copy this.
Yeah. First one completed, no? Only first one and this. Now, what is the third one? Third one I told the valency of the element, right? Valency of the element. So valence of the elements. If larger the valence electrons, conductance is least. Least means low. See, for example, sodium, magnesium, aluminum. Now, what is the configuration of sodium? 281. Magnesium 282, 283. The valence electrons, sodium is 1, right? Sodium is 1 valence electron. Here 2 electrons, here 3 electrons. So which becomes fast cation. So in chemical bonding, we discussed it. Not chemical bonding, periodic table, I think. So cations, which is earlier the ease of formation of cations is, what is the ease of cations formation is sodium is greater than, magnesium is greater than aluminum. Why? Because by losing of 1 electron, sodium becomes Na plus cation. By losing of 2 electrons, so magnesium to become stable cation, it has to lose 2 electrons. So aluminum also, it has to lose 3 electrons to become stable cation, Al plus 3. Now which becomes early electron transfer takes place in first case only. That means the conductivity is the lower the valency electrons, conductivity is more. Electronic conductivity is more. That means, what is the simple? The electronic conductors is inversely proportional to number of valence electrons. Finally, what is the conclusion? The electronic conductance is inversely Ly. 1 minute. Inversely proportional to the valency electrons. Valency electrons. Correct, ma'am? Note it down. Okay. Next, now we are going to another page. You understood what is the conductance and electrolytic, electronic, and what are the factors affecting and all. Now we are going to electrolysis. Now entering to real chapter. Next, come to the electrolysis summary. What is meant by electrolysis? Note down electrolysis. Anybody else electrolysis definition? Electrolysis is the decomposition of the substance into constituent molecules by passing electric current is known as electrolysis. What is the decomposition of, take now definition. Decomposition of chemical substance into constituent molecules by passing electric current. Is known as electrolysis. See, for example, H2O liquid, electrolysis becomes H2 plus gas. Okay, electrolysis, electric current passes through, or water is subjected to electrolysis. Okay, hydrogen gas and oxygen gas liberated, oxygen gas are formed. Just I am giving one example only. Now we are going to discuss about the what are the requirements for the process of electrolysis and types of electrodes, and I will give that total big table. This is very important. Now, so can I clear this one? Okay. Series. Now we are going to discuss the one process, electrolysis process. What are the requirements for electrolysis? Means requirements are, one is electrolytic cell, okay, comma, electrolytic solution, comma, next electrodes, next external source of EMF, battery, like that is the external source of EMF, external EMF, or like a battery. Now, all of you draw the electrolytic cell diagram, neat diagram. I'm drawing rough diagram, you can write a neat diagram. This is electrolytic cell, right? And this electrolytic cell, two electrode rods are dipped. These two electrodes are connected to external source of EMF like battery. Take this neat diagram. This is first one. Right. And this is these are the electrodes. And this is the electrolytic solution. Suppose I am taking here aqueous solution of electrolyte is aqueous KCl I am taking. You know, external source of EMF, positive and negative. The electrode which is connected to positive terminal of the battery is known as anode. The electrode which is connected to negative terminal of the battery is known as cathode. Right? The electrons flows from anode to cathode. Here, this is the electron flow. What is the direction of electrons? Now here, this is the direction of electrons. And come to here. Direction of electrons. See, in this electrolytic solution, electrons are released from cathode. At the same time, what is the tendency of anode? Electrons absorbed or electrons moves towards anode. This is the direction. Same. This is the direction of electrons. Understood the cycle process? Okay. Now, these are this is the arrangement of electrolytic cell diagram. Now come to the electrolysis at electrolysis reactions. By passing electric current, electrolysis takes place. Electrolysis reactions. Same, what are the electrolysis reactions? KCl dissociated as K plus and Cl minus. But aqueous means water also is there, right? Water also dissociated. Water also dissociated as H plus and OH minus. But here two cations and two anions are there. Again, here two. Okay. Electrolysis reactions note down. KCl gives rise to K plus and Cl minus. H2O gives rise to H plus and OH minus. You know, two cations and two anions are there. What are two cations? Potassium plus cation, H plus cation, Cl minus anion, OH minus anion. Here, what is the cation? Positive means it becomes neutral. Electron is required. So electron required means in that electrolytic solution, who will give the electron? Cathode only gives the electron. That means all cations moves towards a cathode. Next, what is the Cl minus and OH minus? It has more electron. To become neutral, it has to lose electron. It has to lose electron means any other person is ready to give the electron, then only it is loose. Now, your anode, what is the tendency of anode in this diagram? It ready to take the electron. So that is electron taker. That means anions migrated towards anode and discharge. That means losing of electron means oxidation takes place at anode. So cation migrated towards cathode plate or cathode rod and takes electron, it becomes neutral. That process is the reduction. That means reduction takes place at anode, at cathode, oxidation takes place at anode. Understood or not? But here the thing is very important. Cl minus and OH minus, two anions are there. Who will run fast towards anode? Chlorine or OH minus? Chlorine. Now chloride ion, it is a single ion. OH minus also single ion, but with the two elements are there. So chloride ion discharging potential is low. That is, I will show some discharging potential order also. You note down here only. Otherwise, you will get confused. Some elements, of course, in electrochemical series, end of the chapter series will come the total. Now here, write some examples. Here I am writing. Note down the decreasing order of discharging potential. 0.1. The decreasing order of discharging potential. Decreasing order of charging potential. Or increasing order of deposition. Increasing order of deposition of some of the ions. Some of the ions are given now. For cation, same. For cation, here for cations, what is the order I am giving? Ag plus is greater than Hg plus 2. Mercury is greater than copper plus 2. Cu plus 2 is greater than H plus is greater than Zn plus 2. Zn plus 2 is greater than Al plus 3 is greater than, so Mg plus 2. Mg plus 2 is greater than calcium plus 2. Ca plus 2 is greater than sodium plus 2. Sodium plus 1 is greater than potassium plus. This is the order. Similarly, for anions, note down. So X minus means halide ions is greater than OH minus ion is greater than NO3 minus is greater than SO4 minus 2 is greater than PO4 minus 3. Here X minus means in that X also that is okay. Iodine minus is greater than, bromide is greater than, chloride is greater than fluoride. Note on this all this point. And now compare now. Among this chloride and OH minus anions, which is discharged earlier, chloride is greater, right? Here see X minus means chloride. So at anode, chloride ion, but I written in this 1 mole only, but in the electrolytic cell certain quantity is there. That means 2Cl minus ion becomes Cl2 plus 2 electrons. Chlorine molecule gas is liberated at anode. What is the name? At anode, chlorine gas is liberated. Now at cathode, so what is the cathode? Cation K plus H plus. We come to this series. So K plus is the highest compared to the, hydrogen is highest. H plus is highest means, so 2 H plus ions takes 2 electrons, it becomes He2. Now what is another product? Chlorine gas liberated at cathode, hydrogen is liberated. So here chlorine is liberated, it's gone out, hydrogen is gone out. Now what left in that solution? K plus and OH minus. So before, try to understand all of you, I'm giving explanation, I'm not writing what I am explaining every point. So electrolysis. During the electrolysis, the reaction occurs and products, some chlorine and hydrogen gas is liberated. So before going to take, what is the electrolytic solution? Aqueous KCl. Aqueous KCl means it is the salt or neutral salt now. Neutral salt means what is the pH value? Here, aqueous KCl, here pH is equal to 7, right? Neutral. So after electrolysis, chlorine is gone out, hydrogen is gone out. So what is left? K plus and OH minus. The resulting solution becomes a basic. Correct now? Basic means the pH of the resulting value, pH of resulting solution after electrolysis. Electrolysis is equal to, or is not 7, it is greater than 7. Why it is greater than 7? Nature of the solution, it is basic. It is basic. Understood? All of you. Note this one perfectly. I will give big table. You only calculate that total. Anion, anode product to cathode product to anode reaction, cathode reaction, everything you have to write. I will give the examples. Try to understand this. This is very important. It is a first, from first part of the electrochemistry, one objective question compulsory, either NEET or JEE mains, from this area also, from based on electrolysis. Electrolysis, I am going to give a big table in that area. Okay, completed. All of you, you remember this part. This part is very important. This what I given this point one series. Cation increasing order, anion increasing order. Right. Now I'm going to change the clear the page. Note it down, all of you. Okay. So next, I'll give another example. Electrolysis of fused or molten KCl. The diagram is same. Electrolytic cell diagram is same. Now, what are the electrolysis reactions? Electrolysis reactions are KCl only dissociated as K plus and Cl minus. Now, at anode, What is anode? 2Cl minus gives rise to Cl2 plus 2 electrons, oxidation. At cathode, reduction. But here hydrogen is not there, no? Only potassium. K plus takes 2 electrons, it becomes 2K. Potassium is deposited at the cathode because it is a metal. It is the metal deposited. Chlorine is gas liberated at the electrode, at anode. Okay. Next, note down this one. Next, see this. Types of electrodes. Here electrodes are electrodes. In electrolytic cell we are using metal rods, right? That is rods. Here types of electrodes. Types of electrodes. Then what are the electrodes are divided into two types. Electrodes are electrodes divided into two types. One is active electrodes. Second one is inert electrodes. Active electrodes and inert electrodes. First one, active electrodes means what? Active electrodes. Active electrode means the electrodes which are take part in the chemical reaction. The electrode which are take part in the chemical reaction during the process of electrolysis. Process of electrolysis. During the process of electrolysis. See, for example, what are the any metal rod? Example, metal rod placed in its own solution. Say, for example, Cu rod dipped in CuSO4 or CuCl2 or CuCO3 taken twice, whatever it is, etc. Cu rod dipped in its own solution can act as active electrode. Understood or not? Zinc rod placed in zinc sulfate solution, whatever it is. Okay, next, second one is inert electrodes. What is that? Second one is inert electrodes. Inert electrodes. So what is meant by inert electrodes means, okay, the electrodes do not take part in reaction during the process of electrolysis. So generally, platinum rods or plates are used as inert electrodes. There is a highly resistance. There is also no platinum PT. I am writing simply. PT rods are used as inert electrodes. But it is a theoretical only. But in the laboratory, instead of platinum, simply graphite rod used as inert electrodes, because platinum is highly expensive, highly more cost than gold also. That means it generally, but theoretically we are saying platinum is highly resistance, but no one can use the platinum rods in the laboratory. That is, instead of that, the cheap product is the graphite rods are used. Note it down this. Okay, start next. Okay, next. Can I move? Okay, now I am giving some examples. Not done. Example means table I am giving. Electrolyte, electrolyte, electrodes, anode, cathode. Next, electrode products, anode, cathode. Next, electrode reactions at anode, at cathode. Say for example, first one, NaCl, aqueous NaCl I am giving. Aqueous NaCl. So aqueous NaCl. What is anode product and cathode? We are using platinum electrodes only. using platinum electrodes. Platinum means inert electrodes. You know, anode product chlorine, cathode product H2. You see that series what I am giving. Chlorine means 2Cl minus gives rise to Cl2 plus 2 electrons. Hydrogen means 2H plus 2 electrons gives rise to H2. This is where I am giving some examples. You have to note it down. This is a molten NaCl by using platinum and platinum. Next, aqueous CuSO4 sulfate using platinum and platinum. Next, aqueous CuCl2 using copper is anode, platinum. Next, aqueous Az silver nitrate and it is platinum and platinum, and aqueous AgCl and platinum. Next, 50% H2SO4, platinum. Next, molten cryolite Na3AlF6, platinum. I'm giving 5 minutes to complete this one. Find the things anode product, cathode product, and anode reaction, cathode reaction. I will ask to everyone. This is very important. From this area, compulsory one question in any type of exam.
So what's the last electrolyte?
Cryolite, Na3AlF6. Na3AlF6. Okay, come on, tell me now. What is the second one? What is the anode product? Tarunya, what is anode product?
So Cl2,
Cathode product?
H2.
I didn't give an H. Where did I H2O?
Sorry. Oh, Na.
Na, sodium deposited. Correct now?
Yes, sir.
Then what is the reaction now? At anode reaction? 2Cl minus plus gives rise to
Cl2,
Cl2 plus 2 electrons. Now cathode reaction?
2Na plus 2Na plus 2 electrons will give you 2Na.
Yes, that is the deposition, right? Okay now?
Yes, sir.
Next, Akshay.
Yes, sir.
What is third one?
So 1 second, I'm
Again?
doing it.
What electrolyte is given?
Aqueous SO4.
Aqueous CS4. How it is dissociated? Cu plus 2. How it is dissociated first? Cu plus 2. SO4
Cu
minus 2.
plus 2
Right?
electrons.
Yeah, no. I am asking this electrolytic reactions, electrolysis reactions. First, you tell that. CuSO4 ionized as Cu plus 2 and SO4 minus 2. And
Yeah.
aqueous means water also is there. Water also is dissociated H plus and OH minus, right?
Correct.
Now, SO4 minus 2 is there and OH minus is there. Two anions are there. In these two anions, which is earlier discharged at anode, that is important. Already I given that order. Oh, combination of sulfate and hydroxide ion, which is earlier discharged. I given
Sorry,
now.
sir?
Now SO4 minus 2 and OH minus. These are the two anions now.
Correct.
In these two anions, which discharge earlier at anode. Above series I given. X minus is
OH,
greater
sir,
than.
OH.
Yeah, very good. If OH minus and discharge, what is the product? Oxygen is liberated at anode. What is oxygen? Oxygen means, say for example, 1 minute. To get 1 mole of oxygen, I am showing now here. 1 mole of oxygen, 4 moles of OH minus ions. 4 OH minus ions has to discharge. It becomes 1 O2 molecule plus 2 H2O plus 4 electrons. See, I will show now. OH minus, OH minus, OH minus, OH minus, right? How it is discharged? OH loses electron, na? Gives rise to OH plus electron, OH plus electron, OH plus electron. That means from these two OH groups, H, one water molecule and oxygen is left. Here from water molecule, one oxygen is left. This oxygen combined to form one O2 molecule and H2O, two water molecules and 4 electrons. Understood? Akshay?
Yes, sir.
Now what is the anode product, what you told now? O2, right?
Yeah.
Next, what is the cathode product? Copper plus 2 and H plus, which is earlier recharged. Observe that I given points. H plus and
Copper, sir,
plus.
copper.
Yeah. If copper deposited, na, Cu is the cathode product. Now come to the reactions. This is that only here. What is the reaction? Anode reaction? 4OH minus, right? Gives rise to.
Sir, aren't you supposed to write it below?
You're
writing it in the molten NaCl part.
Oh, I'm sorry. That is second. 1 minute. Okay, you are completed that one, right? Okay, fine. Yeah, this is one minute. Yeah, this is already wrote Cl2 and sodium, right? So 2Cl minus gives rise to Cl2 plus 2 electrons. Here 2Na plus plus 2 electrons gives rise to 2 Na, sodium deposited. Come on, now here copper, what is the O2 and Cu? O2 means 4 OH minus ions has to discharge. Becomes O2 plus 2H2O plus 4 electrons. Now here 4 electrons released means 2 moles of copper has to deposited, right? Plus 2 plus 4 electrons gives rise to 2 copper. Now what is the next one? Yes. Okay. Now I'm asking to Krishna. Hello. Krishna is there? Krishna. Krishna. Not there. Okay. Ajay.
Yes, sir.
Yeah. What is the third one? Third means fourth one.
CuCl2, sir. Okay. It'll be at the anode it will be Cl2, and at the cathode it will be Cu, and the reaction will be for the 2Cl minus will give Cl2 plus 2.
Please, wait. What is the? Tell me what is the anode product and cathode product?
Anode is Cl2,
Cathode.
Cu.
Anode product is wrong.
Oh.
Why? Because I given active electrode, na. See, my anode is active electrode placed. Copper rod dipped in its copper chloride solution. You think about that one. Copper rod, anode rod is the copper. Then it can act as active electrode, na. Active electrode means what? It take part in the chemical reaction during the process of electrolysis. Is it right?
Yes. Yeah.
So that means that one is the platinum electrode, cathode is the platinum electrode, anode is the copper electrode. Then copper rod itself it is disintegrates. How it is disintegrates, you know? Cu. Copper rod is the neutral, na? Cu0. Copper rod gives rise to Cu plus 2. Copper rod itself is small pieces, disintegrates like Cu gives rise to Cu plus 2, Cu gives rise to Cu plus 2, Cu gives rise to Cu plus 2, like that. So all copper rod quantities disappears after completion of the electrolysis. Try to understand all of you. The copper rod Cu gives rise to Cu plus 2. That means oxidation. The same Cu plus 2 again migrated towards cathode and takes electrons deposited as a copper metal at the bottom of the platinum rod. So after completion of the electrolysis, you remove that electrodes, only platinum rod comes out. Copper rod is completely disappears, only wire will come out. Point understood? How much quantity of copper rod is put in that electrolyte, that much quantity is of pure copper is deposited at the bottom of platinum cathode. But in this case, you remember, after completion of the electrolyte, level of electrolyte does not change. This is objective question. What is the level of electrolyte? Only rod is disappears and at the bottom of cathode is deposited. But the level of electrolyte, what we are using CuCl2, that is not ionized and dissociated and deposited. Understood all of you? Ajay?
Yes, sir.
Remaining students also understood? Now what is the anode product means? See this. Anode product is, what is the anode product? Cu plus 2. Because at anode oxidation takes place now. And again cathode product Cu. Now what is the reaction? Anode reaction? Cu rod gives rise to Cu plus 2 electrons. And here same Cu plus 2 takes 2 electrons, it becomes 2 Cu. Okay. Next. The Krishna, are you able to listen my voice? Krishna. Okay. Manas Gowda. Manas Gowda. Manas Gowda. Nidhi.
Yes, sir.
Yeah, yes, tell me, ma'am. What is that?
Aqueous AgNO3, sir.
AgNO3.
At the anode, oxygen is released, and at the cathode, Ag is released.
At cathode, very good. Ag not really.
Oxygen, O2.
At cathode, at anode, O2, very good. At cathode, silver deposited, not released. It is a deposit. Okay.
Yes.
Now, what are the reactions now? Anode means 4OH minus gives rise to O2 plus 2H2O plus 4 electrons. Here 4 electrons releasing means 4 moles of Ag plus takes 4 electrons, it becomes 4 Ag deposited. Okay?
Yes, sir.
Right. Okay, fine. Very good. Next, I am asking to. Okay, Nidhi not responding. Manasa Gowda not responding.
So I just said the previous
Yeah, sorry. Nidhi, you only, right?
Yes, sir.
Pawan CS.
Yes, sir.
Tell me now for this answer.
At anode, it's Cl2.
Anode.
Cl2.
Just to think about what is anode electrode. I put the active electrode, right?
Yeah. Sorry, sir. I did not see.
I see this like a copper. I give an active electrode, anode.
Ag plus 2.
What is the valency of?
Ag plus, sorry.
Very good, very good. Ag plus, not plus 2. Okay, next term.
Next is Ag.
Very good. What is the reaction? Ag gives rise to?
Ag gives rise to Ag plus 1 electron.
On, and this one, oxidation reduction.
Yes, sir.
Ag plus takes electron, it becomes a Ag. Okay, right, very good. Next time asking another person is that Murari, T.S. Murari, Rakshita C. Aditi Sinha, Aditi. Aditi Sinha. Hello. Calling, I am calling Rakshita C. Okay, Sarah.
Yes, sir.
Come to what is that one?
So at anode O2, cathode H2.
What is my anode?
Anode O2,
Cathode.
H2.
Anode is wrong. cathode is right, H2. What is this is again 50% H2SO4. Not, you know, in 11th standard I do in its compound chapter, preparation of H2SO4. Preparation of H2SO4 by electrolysis method, that only example. Here 50% means, try to understand all of you, not completely dissociated. 50% means 2HSO4 minus 2H2SO4, H2SO4, 2H2SO4, right? 50% means partially dissociated, not completely dissociated. See, 2 moles of H2SO4, how it is dissociated? 2H plus 2HSO4 minus. Bisulfate ion, not sulfate ion. Now in this dissociation, anion is HSO4, means at anode, see this, 2HSO4 minus becomes H2S2O8 plus 2 electrons. This is a per-disulfuric acid. Per-disulfuric acid, that is the anode product. And at cathode, what we are saying correct. At cathode, what is the 2H plus ions takes 2 electron, it becomes H2. Now what is the anode product? Per-disulfuric acid. But in the first year now, H2SO4 again mixed with water, it becomes oleum. Oleum and H2O2, iodine peroxide. What we are taking consider as, what is the anode product? H2, S2O8, cathode product H2. Same, that reaction you can note it down, all of you. 2H, not H, direct anode reaction. What is the anode reaction? 2HSO4 minus gives rise to H2S2O8 plus 2 electrons. Cathode 2H plus 2 electrons gives rise to H2. Okay. We want this reactions noted down side. Now I'm cleaning this one, rubbing this all this. Now I am clean this because next reactions I have to write here. Note it down. Next, listen, cryolite. What is a cryolite? Say this. It is the molten cryolite Na3Al. First, it is split into two products. What is a Na3AlF6 means? First, it is split into two molecules. What are two molecules? 3NaF plus AlF3. Here, AlF3 only can act as electrolyte. So here, for balancing purpose, 4 moles of AlF3 dissociated as 4Al plus 3 plus 12F minus. Now at anode, note down all of you side, not in this table. At anode, so what are the anions? 12F minus gives rise to 6F2 plus 12 electrons. At cathode, what is the 4Al plus 3 plus 12 electrons? It gives rise to 4Al, right? This is many times, this is even metallurgy, one more chapter is there. That also is repeated here. Extraction of aluminum. This is many times asked in JEE mains, number of years, not continuous years, different years are asked. What is the question, you know? What is the ratio of the anode and cathode products when molten cryolite subjected to electrolyte? Subjected to electrolysis by using platinum electrodes. Question is, what is the ratio between anode product and cathode product when it is subjected to, and means molten cryolite subjected to electrolysis by using platinum electrodes. So what are the answer? Your anode product is fluorino. Cathode product is aluminum. So now anode reactions 12F minus FF minus Q/2 6F2 plus 12 electrons. Cathode reaction 4Al plus 3 plus 12 electrons Q/2 4Al. 4Al, right? Note down all of you. What is TS Murali? Your mic is not working. Huh? What is the problem? Check it and come to. Hello, Murali, Murari. Okay, this table is very important. Note down. Okay, right. Okay, okay. Okay, now, so I move to the next page. Take the snap for this, otherwise note it down. Table is very important. Now I move into other page. Next, Chem. Faraday's laws of electrolysis. Next one is very important. This also. Faraday's laws of electrolysis. Here, two Faraday's laws are there. Now, first Faraday's first law. Faraday's first law. So, what is the Faraday's first law? Listen, the amount of the substance deposited or liberated or dissolved at electrodes during the process of electrolysis is directly proportional to quantity of charge passes through it, is known as Faraday's first law. So what is the Faraday's first law means? The amount of the substance liberated or deposited. If it is gas, liberated. If it is solid, deposited. Or if it is liquid, dissolved at electrodes during the process of electrolysis is directly proportional to the quantity of charge passes through it. Passes through electrolyte. This is a statement. What is the amount of the substance liberated or deposited or dissolved at electrodes during the process of electrolysis is directly proportional to the quantity of charge passes through electrolyte. Okay. Now see this. Suppose M is the mass of substance deposited or liberated, or okay, whatever it is, M is directly proportional to Q. This is the first law. Or M is equal to some proportional constant small e into Q. Here small e is the electrochemical equivalent.
Ready, Kar.
What is small e? Small e is the electrochemical equivalent. Electrochemical equivalent. See, from that equation 1, what is the electrochemical equivalent? E is equal to M by Q. Or if Q is equal to 1 coulomb, then E is equal to M. Now, what is the electrochemical equivalent definition? Electrochemical equivalent definition is, what is electrochemical equivalent definition?
So 1 minute.